Hi guys, myself MANOJ.M. Welcome back to the MANJULA.K MANOJ.M YouTube channel. Guys, in the last video, we have done the schematic symbol, DC analysis and transfer response of the NOR gate. In this video, we are doing about the AND gate. We are using for the AND gate the symbols of the NAND and not gate, that means the inverter. In this video we would do like this. Before that, let me go through some part of the theory as usual and then come back to the cadence. Then we came to know to do the things and verify the outputs. Let's do that. I'm opening this. In this video we are doing of AND gate CMOS, VLSI AND gate. Okay, done. Let's write the symbol of the AND gate symbol. Then this. Okay, it will be clear. That's it. Okay, A, B, Y. Okay, we know that Y is equal to A dot B. Let's write the truth table here. Truth table. Okay, A, B, and Y 0 0 0 1 1 0 1 1. We know that in AND gate the output becomes 1 only when both the inputs are 1 1. Remaining all these things are 0. It's simply opposite of the NAND gate. Let me write the schematic here. Schematic. First we need to write the schematic of the NAND gate and then the NOT gate. That's it. That means the inverter. Okay. We know that in the NAND gate the NMOS are in series. Let A, B, this substrate is to the ground. Okay, sub, and this substrate is also to the ground. Sub, this one symbol. This one is the gate, this one is the gate, this one is the source, this one is the drain, this one is the source, and this one is the drain. Let it go little bit up. Then two PMOS are in parallel. This one A, this one B, gate to gate, and then that substrate to the VDD, then the symbol and substrate to the VDD, and then to the VDD. Okay, this one is the source, this one is the source, drain, drain. Next here is the output. Then it should be connected to the inverter. Okay, this one to the gate of PMOS, this one to the gate of NMOS. Then write this. Okay, then write this. Then this to the ground. Write ground here also. Then this one is the drain, this one is the drain. This substrate to the ground, this substrate to the VDD, sub. This one is the gate, this one is the gate, this one is the source, this one is the source. Connect PMOS source to the VDD. Okay, connect from here to here. That's it. Here, right, Y is equal to A dot B. I'm not using the scale. That's why that's coming like this. I hope you are understanding what I am getting to tell you, what I am writing on the screen. You are getting that. If you have any doubt, you can comment in the comment section. Then I move to the cadence. Then click on this. Then click on terminal. Then enter the virtuos and then press on enter. It will open. Then click on files. After it comes, click on files, then click on new, then click on cell view, give the name as and. Okay, then change it to the VLSI. Okay, and then click on OK. The schematic where we need to do that will open. It will take some time. Yeah, it's opening. It will take some time, bro. Yeah. It opens, then maximize this, then click on I, then click on brush, then click on VLSI, then click on NAND, then click on close, then hide this, paste this here, then click on escape, then click on hide, then yeah, we need one inverter, click on brush, then click on inverter, then close, then hide this, yeah, then place this here, then click on P. Yeah, we know that the inputs are A, B, VDD and G and D. Then click on enter, place A here, place B here, place VDD here, place G and D here. Then click on W, connect B to B. Then click on W, connect A to A. Then click on W, connect VDD to this VDD, then click on W, connect this to this, then click on W to here and then connect to here, then click on W, connect here to here, okay, then click on P, yeah, then click on output here, give the name as weird, then click on enter, rotate this, place this here, then click on W, connect this V out to V in, okay, then click on W, connect the V out to this the V out, okay, then click on check and save, then minimize this, check here once also schematic check completed with no errors, VLSI and schematic saved, it is showing like this, then maximize this, then click on create, then click on cell view, then click on from cell view, then click on OK, yeah, we know that the left pin are A and B, then place this here, then yeah, we know that top pin is that VDD. Then click on this, then cut this and put the GND here. Then click on OK. It will come like this. Give the name as and gate. OK. Then click on this, remove this. Then click on check and save. Then put here. Then minimize this. Then minimize this. Okay, VLSI and symbol saved. Okay, then click on file, then click on new to verify the things, then click on cell view, give the name as and one, then click on OK. Yeah, then maximize this, then click on I, then click on brush VLSI, and then click on and then close this, then hide this. Okay, then click on escape, then press P. It is in output, give the name as Vout and then enter and then rotate this, put this here, then press on P, then move to the input, then type A, B, VDD and then G and D, then click on enter, put A here, put V here, put VDD here, put G and D here, then click on escape, then click on W, connect this to this, connect B to B, connect then A to A, then connect VDD to VDD. Okay, then connect V out to V out, then click on this, check and save, then minimize this, then check schematics, check completed with no errors, VLSI and one schematics saved, then click on launch, then click on ADL, then click on this symbol. Yeah, then we know that, then move to DC, enable this, give the DC voltage as 0, then click on apply, okay, then move to the VDD, then click on DC voltage as 1, enable this, then click on apply. I will first give for A, then for B, okay, then click on pulse, then click on enable, then give voltage 1 as 1 volt, voltage 2 as 0 volt, period as 40 nano and the pulse width as 20 nano, then click on apply, okay, then click on B, then click on enable, then click on V pulse, here 1 0, this is 20 nano, then pulse width is 10 nano, okay. Then click on apply, then click on OK, right. Then click on outputs, then click on to be plotted, select on schematic A, B, then move on to this side, then click on weird, then click on analysis, then click on choose, then type the stop time as 200 nano, then enter on tab, then click on moderate, then select OK, then run this. Yeah, it will take some time. Yeah, you can see that when A and B is 1, the output is 1. Yeah, you can check this also here. We have written here when A and B are 1, the output is 1. Other time that should be 0. Yeah, you can check this in the other time. All the times that would be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Yeah, the output came as we needed. Then minimize this. Then come to here. Then make it the full screen. We know that for the DC analysis we need to remove this A and B, then click on the right click, then delete it, then click on hide, then click on browse, then click on analog lib, then type V pulse, okay, V pulse, then click on enter, then give the voltage 1 as 0 volt voltage, 2 as 1 volt, okay, then click on tab, period as 40 nano and the pulse width as 20 nano, then click on tab, then hide this, then place here, then click on escape, then click on W, connect here to here, then click on W, connect here to here, then click on W, connect from here to here, then click on escape, then click on check and save, then minimize this, then came to here, then remove this, then click on delete, remove this, remove this, remove this, remove this, then disable the transient analysis, then click on the analysis, then click on choose, then move to the DC, save DC operating point, component parameter, then click on select component, then click on here, then click on DC, VDC, DC voltage, then click on OK, then click on here, give the start as 0 and stop as 1, then click on apply, then click on OK, then click on outputs, then click on to be plotted, then click on select on schematic, then select here, okay, then click on weird, then run this, okay. It will take some time, bro, for the DC response. Yeah, the DC response has came, you are seeing on the screen. Yeah, in this video we have made the AND gate. We used the NAND gate and inverter to make the circuit, and we verify and we created the symbol. We verified the transient response, and then we have seen the DC response. Yeah, I hope in this video you came to know how to make all of these things. Yeah, I hope this video is understandable to you. If this video is understandable, hit the like button and send it to your friends who are learning these concepts. Guys, see you in the next video, guys. Thank you for watching.